Welcome, everybody. Thank you for joining this session. My name is Blaise Pele. I'm a Principal Mobile Solution Architect at AWS. In this session, I will be talking about powering real-time serverless applications with GraphQL and AWS AppSync. In terms of what we're going to talk today about, here's the agenda. First, we are going to start talking about GraphQL, just to kind of level the playing field, make sure everybody has a good understanding of what GraphQL is. We'll then talk about AWS AppSync and talk about how it's a game changer when it comes to implementing APIs to connect your applications. We'll look, of course, at the features, integration, and security. And then we'll take a look at the real-time with subscriptions, and we'll take a look at a demo to kind of showcase how subscriptions can help you engage with your customer and implement those real-time features and functionality. Okay, so let's take it all the way back and talk about GraphQL. Just what is GraphQL? That's a question you hear a lot. So what I can tell you for sure is that the graph in GraphQL has nothing to do with graph databases. GraphQL is a query language that allows you to describe your data. So it allows you to describe your data. Once you've described your data, you can actually use GraphQL to ask exactly what you want. So this is really important and efficient for clients. So if you ask for a tagline, you then get predictable results. You'll get a tagline returned back. So there's no guessing or trying to assume what is going to be returned back. It is a very specific, it's a data language that allows you to be really specific. Now, it's often good to use example or illustrations to explain a concept. So let's try to do that here to explain what GraphQL is. Let's start with an application. This could be any type of application. It could be a web application, an e-commerce application, a chat application, a financial application. It has a web version and a mobile version. But both versions of this application return data from multiple data sources. These are the ones that you see here in green, blue, and red. Now, if we look at our traditional way of interacting with APIs, you would typically have 3 different endpoints to interact with data. So you would have endpoint A, B, and C to return to data for the different parts of your application, the different parts that your application show to your users. Now, these endpoints could be using one data source, or they could be using multiple data sources. So let's look at what would happen in actuality, right, if you were to use these applications. So typically what happens is that when you have a mobile application, your mobile application has a smaller real estate, right? So it needs to show less data to users. It also needs to return and fetch less data. Because it's a mobile application, we often optimize it to work in mobile scenarios where we have less control over the connectivity and maybe a bit less performant internet or Wi-Fi connection. So typically we want to fetch a bit less data than what we would do on our web version that's running on our desktop. Now, what happens is that with the mobile version, we want to fetch less data. But in these traditional systems, we can't really control how much data is sent back. So we end up overfetching. And even on the web version, we can't control that. So we may end up overfetching as well. So you can see the whole payload that is being returned here is not really necessary. So this is just for the first section. Then we often have systems where the data that we fetch from the next system, system B here, the one in blue, is dependent on the data that was fetched from the first system. This means that we cannot actually start fetching from system B until we've resolved all of our queries for system A. So not only are we overfetching, we are also fetching sequentially. And we will repeat that potentially with system C. So we are fetching sequentially, there's a lot of overhead, and we cannot control how much data is supposed to be sent back. This is what would happen with a traditional system. When you look at how things are done with GraphQL, to start with, you only have a single endpoint. So GraphQL allows your application to talk with a single endpoint to resolve data from multiple data sources. Now, this allows us to be a lot more efficient, right? We have a single request instead of multiple requests. The other good thing about GraphQL is that we can actually control the data that is sent back. We have control over the selection of the data for each query. This allows us to optimize for mobile and also for web. And it also allows us to optimize for the different use cases that we have. Now, as you saw in the previous slide, our GraphQL endpoint interacts with multiple data sources. And those could be traditional data sources, but there's no limitation here. One of the good things about GraphQL is that it provides a certain level of abstraction for our clients. So GraphQL can connect to microservices even in our backend. And our clients do not need to know about that, right? And you can also have a mixture of different data sources. So in this case here, we have GraphQL interacting with a traditional database, maybe a SQL database, then interacting with an HTTP backend or a microservice, and then interacting with a NoSQL database. So we have a lot of flexibility here, and this does not impact how our application on the front end, how our clients interact with the GraphQL API. So there's a lot of strengths here. Essentially, what we've seen is that with GraphQL, you get exactly the data you need, nothing more, nothing less. You don't need to assume or try to guess what is going to be returned after you've made that request. The way GraphQL does that is by being a query language for APIs and a runtime. But let's look at the query language part and some of the important components of GraphQL. So GraphQL uses a schema definition language to define the specific types that are available to the API. In the schema, we find types. Here, you can see that we have a type user, and a type is made up of fields, and each field has its own type. You can see here that we have, for example, a username that's of type string exclamation mark. Now, the exclamation mark means that the field is mandatory. That means that when I request a user, I am guaranteed to have an ID and a username. So you can think about this as a contract, right? This is the guarantee. Within the schema, you also have operations. So you have queries. This is kind of straightforward. This is what you use to fetch data. You have mutations that you use to update data. And then you also have this concept of subscriptions. Subscriptions are tied to mutations, and subscription can be triggered to send your client real-time information about changes that are made via mutations. So it's a new concept specific to GraphQL that is really interesting and lets us build really cool applications. So these are the different operations that you have: a query, mutation, and subscription. They all look kind of alike. One of the things that you'll see here in these purple boxes is that you have control over the selection set. By default, you can request all of the information to be returned for you. So if I'm getting a post, I can say, well, give me the ID, the title, the author, and the date. Similarly, with a mutation, I can request all of that information after I've created the post. And same thing with the subscription. Now, the cool thing here is that this set is called the selection set. The selection set, as the name specifies, allows you to specify what data you want returned from your operations. So think about the example that we gave earlier with the mobile and the web version of the application. The selection set allows us to specify what we want to get back. So if we want to be really conservative with the amount of data that is being returned, we can really kind of shrink that down. And if we need more data, we can specify more data. But this is really something that is at the fingertip of developers when they start interacting with an API. Okay, so we've seen GraphQL and we talked about the query language, but GraphQL in itself is only a specification. It doesn't provide a service that actually gives you access to a GraphQL API. So what are you to do, right? You could go about it several ways if you wanted to implement a GraphQL API. Of course, you could stand up your own, but that comes with a lot of overhead. That means managing resources and keeping track of resources. Another option is to use AWS AppSync. And AWS AppSync is a GraphQL compliant service that allows you to build applications into AWS Cloud that scale with your usage and provides you with a ton of functionalities like offline, real-time, and conflict resolution. So AppSync, I talked about the fact that it's a GraphQL compliant solution, but it's not just a GraphQL proxy. AppSync allows you to connect your applications to any data source that you have into cloud. So AppSync allows you to create any type of application, from enterprise applications to applications that need real-time engagement to applications that need to work offline and then quickly synchronize changes in data when they come back in online. So much more than just a GraphQL proxy. The way AppSync works is that it connects your applications on the front end to data sources in the back end. Out of the box, AppSync connects, allows you to easily connect with sources, data sources like Amazon DynamoDB, Amazon Aurora, Amazon Elasticsearch, AWS Lambda, and you can connect AWS AppSync to any public HTTP data source. You can connect AWS AppSync to any AWS service, and we also have a concept of local data sources. And these are data sources that you can use to push mutations to trigger subscriptions. These local data sources allows you to actually do mutations that don't store data anywhere. Let's dive a little bit into AppSync. Into the AppSync implementation. So the first thing that I want to point out is that AppSync is built using AWS best practices when it comes to security. So one of the advantages that you have when it comes to using AppSync is you've got a lot of features that'll help you keep your API secure and implement authorization rules. But if you look at the way AppSync works as a GraphQL API, the starting point, of course, probably guessed it, is the GraphQL schema. This is where you do your data modeling. So a lot of time I like to think about it as starting with the client requirements and trying to think about how clients are going to interact and access your data. The work is done into GraphQL schema where you define your types and operations. AppSync then is the runtime API, the runtime that we talked about previously. If you remember, we talked about the query language and the runtime. AppSync is that runtime. And AppSync provides resolvers that allows you to connect your request to data sources, right? Resolvers are that business logic that you can implement that actually tie your request to your resources. We call them resolvers because they resolve your request with your data sources. And in this business logic that is implemented using Velocity Templates, VTL for short, you can really implement business logic that is custom to your organization, to your enterprise, to have it do exactly what you want. So these are resolvers. Now, there are two types of resolvers. The first one is a unit resolver that allows you to talk to a single data source. We also have pipeline resolvers. Pipeline resolvers are really handy when you need to have a single operation that interacts with multiple data sources. So you can think about a situation where you need to access data in a SQL database to get started, but you need to add to that data by fetching additional resources from a NoSQL database. And maybe as a last step, you need to process that data in a Lambda function or by calling another system that you've provisioned. And you can do all that in a single request by using pipeline resolvers. Pipeline resolvers allows you to create functions that you can reuse in multiple pipeline resolvers, and these functions access data sources in sequence. So this is a pretty strong tool that you can use for these more complex scenarios where you need to interact with multiple data sources. Now, we also have cases where you may not want to implement your business logic in your VTL resolver. You may have a Lambda function that already implements the business logic. And for this scenario, you can use what we call direct Lambda resolvers. Direct Lambda resolvers essentially allows you to skip the VTL resolver and implement your business logic directly in your AWS Lambda function. So in this case, there's no VTL to write. You just implement your Lambda function, and your Lambda function then becomes responsible for implementing the business logic and for fetching the data that you want to make available at your client. So I talked about the security aspect of AWS AppSync. AWS AppSync integrates with services such as WAF, that I should mention, that allows you to protect your APIs. But it also allows you to interact with your AWS AppSync using different modes of authorizations. That means that you can use different mechanisms to authorize requests that are being sent to your APIs. Currently, AWS AppSync supports API keys, supports Amazon Cognito User Pool as a mode of authorization. It supports OpenID Connect and AWS Identity Access Management to grant access to your API. You can also use the AWS Lambda in a pipeline function as a first step to implement custom business logic to authorize requests. That being said, we're also looking into making AWS Lambda kind of a first-class citizen to allow you to implement your custom authorizers. So I would stay tuned for that. This is something that we're looking into. To give you a quick overview of how you would use these different modes of authorization, the first one is the API key. Now, API key allows you to provide access control via static key that you provide in your API. So if you look at something like a curl command, if you wanted to interact with an AppSync API over HTTP, you would simply include the XAPI key and provide your key. The key is provided by the AppSync API. So the API key is great when you're getting started, when you are dealing with an AppSync API that is kind of a public API, when you have no specific authorization requirements, or when you want to implement a B2B or machine-to-machine type of interaction, right? When you vend it to key maybe to a third party securely, and that third party has access to the key. One thing that I should mention here is that you can have multiple API keys set up in your for your AppSync API. So you can use multiple API keys with different third parties. We also support Amazon Cognito User Pool. So this is a great mode to use if you have an application when users are signing in using the Cognito User Pool. Once you've signed in with Cognito User Pool, Cognito returns to you JSON Web Tokens, JWTs for short. And then you can use those JWTs to authorize your request towards AppSync. So when you send your request to AppSync, AppSync looks at the JWTs, verifies the signature, and verifies the information with Cognito, and then grants access. You can also use some of the directives that we have, like the AWS auth directive, to specify, for example, which Cognito user group should have access to a specific field, to a specific operation. You can use something like OpenID Connect. So here you can do things like implement granular access controls based on the claims that are available in your JWT token. So this is somewhat similar to Cognito, but this is something that you would use if you are already using an identity provider that's OIDC compliant, and you're using that identity provider to authenticate your users. You would do the same thing, use the JWTs to get your request granted. Here, you can use the claims, and you can access the claims in your resolver business logic, right? So into resolver, you can actually check the claims that are available into JWT and take action to grant or not grant access based on the values that you've received. Last but not least is AWS IAM. Now, this is a great mode to use if you are accessing your AppSync API from a backend system. So with this, you can implement granular access control with IAM policies. So you essentially write a policy that grants access to an API, and you use the specific action AppSync column GraphQL. So this is great if you're using something like an EC2 instance or AWS Lambda functions to access your AppSync API. Now, these are pretty powerful tools, but it's even more powerful than you think because AppSync allows for multi-authorization, meaning that you can use all of those authorization modes that I just went through in a single API. So let's take this flight type for example. Now, we could have Cognito users that are logging into an application that are part of a frequent flyers group. And using the AWS Cognito User Pool directive, we can grant access to all of the information in this type to our Cognito users. Then we may have a public API that's accessing this information, and we only want to grant access to airport code and to airport name. Then we may have a Lambda function that's using the AWS IAM authorization mode, and this Lambda function is updating information about the arrival. So we granted access to the ID and to some additional information in this type. So you can see how we can really leverage the multi-authorization to enable different access patterns and access from different systems. Next, let's talk about the real-time with GraphQL subscriptions. So AppSync implements subscriptions using WebSockets. And this is really flexible. With secure WebSocket connections, AppSync WebSockets can scale to millions of clients. So you can have millions of clients connected to AppSync and listening for real-time changes. Now, as I said, subscriptions work and are pegged to mutations. So subscriptions are triggered, notifications in subscriptions are triggered when a mutation is done via AppSync. And this is for any type of mutation, regardless of the data source that is being used. Let's take a look at how this actually works. So I have an application that's connected to AppSync via multiple via WebSockets, right? All of these clients, I've come online and set up WebSockets to listen to specific changes. One of my clients does a mutation to AppSync. AppSync resolves that and turns that into a put item operation on a DynamoDB table. When that change is made, the result is pushed to all of the clients that have subscribed for it. In this case, you see that we are sending the notification to all clients because they have subscribed to all of the changes. But you can also use the arguments in your subscription to filter the subscriptions. So here we have 3 clients that wanted to see the specific change because they requested something really specific. And then we have another client that wanted to see something else, has a different argument, and is doing a different type of filtering. So this client gets another change while the others don't see that change. You can also trigger subscriptions from a backend system. Here we have a AWS Lambda function that does a mutation on an AppSync API, again, resolves it into a put item operation on the DynamoDB table, and that is pushed to our client. We can also handle out-of-band requests. So here we have a change that is being done directly onto DynamoDB table. The DynamoDB table triggers a DynamoDB stream that then triggers a Lambda function that pushes the mutation to our local resolver. Remember, the local resolver is something that you can use to push information without writing it anywhere. But that mutation then triggers a subscription. So we get that sent to our clients. Now, AWS AppSync real-time WebSockets is really a game changer because it allows you to build applications that scale without worrying about setting up all those WebSockets. AppSync takes care of the connection management, the scaling, the fan out, the broadcasting, and provides metrics that you can use to track how your subscriptions are doing over time. That being said, let's jump into a video and demo to showcase how subscriptions work. And what I'm going to do here is showcase a chat application. Now, it's a chat application, and in this chat application, we can do things that you typically do in a chat application. You know, you can have direct messages with other folks into application. You can do group conversations where you need to talk to multiple folks in the application. And you can also, want to have notifications about different things that are going on in the application. So for example, getting like updates on a conversation that you're not necessarily following. So you can see that I'm logged in on the right as myself, and I've got Sewa and Karel that are logged in as users in the other applications. I logged out and I'm going to log in again here. You can see that I'm using Amplify to implement authentication here. So I logged back in as myself. The first thing I'm going to do here is kind of show you the layout. But one thing that I want to show you is I've connected my application and I've got one WebSocket set up with multiple subscriptions. So I only need one WebSocket and I can set up multiple subscriptions. The ones that I really want to pay attention to is the onMessage2 subscription and the onMessageFrom. You can see that I'm using a to argument to filter on the specific ID. So the onMessage2 subscription is listening for new messages that have been sent specifically to me. And I am filtering that so on my own ID. And I've implemented business logic to make sure that I'm only receiving notifications that pertain to me. So I'm going to start a new chat with Sewa. And you can see that as soon as I do that, the chat appears on her side. So that's another subscription at play here. Okay, so I open both chats in both windows. And I think the first thing that I can do here is simply send a message. So let's take a look at that. Send something really simple. And as soon as I send that message, I've received that message on the other side. There's no polling going on here. This is subscriptions at play being triggered by mutations. Same thing here. So let's look at what that looks like. Again, I've got all of my subscriptions set up, and here I have the specific onMessage2 subscription. And you can see that into data, payload, I've got the information about my subscription. And if you pay attention to the to field, the to field is set to Brice. So that's me. and I was filtering specifically for subscriptions sent to Brice. So that's what I got. Now, the other interesting thing about subscriptions is you can peg a subscription to multiple mutations. So what we saw here is the subscriptions pegged to a create event. But let's look what happens when I send a message with a picture. Well, AppSync rocks, right? Everybody should know about that. Now, I've sent a message, and you can see that on the right, I've already received a message, but I haven't received the picture yet. Now, what's going on in the background is that my Lambda function is processing this image and turning it into a thumbnail. So that takes a bit of time. So two things happened. I received a message, and then I received an updated message with information about the thumbnail. So what does that look like? Let's look at the first thing we received. My onMessage2 subscription. When I created the message, you can see that there's no reference to a thumbnail here. So this was triggered by a create message. And then I've got a second notification that is triggered with reference to my thumbnail. This is triggered by an update message with the thumbnail information. So I've got one subscription pegged to two mutations, and one that is triggered by a Lambda function, right? So this is a backend system that is triggering the mutation. Okay, so that is a one-to-one scenario. Let's take a look at one-to-many with a chat. So I think what I'm going to do here is I think I need to create a chat. So I am going to go and create a chat, a new chat room. Provide a chat name, and then I am going to select a couple of folks from my attendee list. Now, I created a whole bunch of fake names here just to show you that you can have a lot of different users, but I'm going to select Karel, and I'm going to select Serwa to be in this chat, and then I'm going to click to go, but I think I'm going to change the name to new meeting before we actually get into it. Okay, so I create the chat, and you can see I have two other people in the chat. You can see the chat appears under Karel, and you can see that the chat also appears here. Okay, so let's try that out. I'm going to send a message, and again, no polling. You see the message automatically appears, right? And here I'm using a different subscription. It's an onMessage and Convo subscription. The difference here is that I'm filtering on the conversation ID, right? I'm sending it to multiple recipients that are part of a conversation. So I can't really filter on who it was sent to. What I can do, however, is filter on the conversation. And again, I've got business logic in my resolvers that makes sure that only the recipients that are part of the conversation can receive the subscription. And then the other thing to point out is I have multiple subscriptions going on at the same time. That's totally possible. So I just sent another direct message, and I see that my onMessage2 subscription was triggered. So you can have multiple subscriptions going on at the same time, and you should feel free to set up multiple subscriptions at the same time. That works as well, right? There's no limitations there. You can have different subscriptions going on at the same time, and they will definitely work. Okay, so you see here again, I've got my onMessage in Convo subscription still set up. In this case, I'm filtering onto conversation ID. Okay, something else to show. Let's see if this conversation, the same thing that we were doing to send an image, let's see if we can do the same thing in a conversation setting where we're filtering on conversations. I think we should see the same result. Yep, everybody should know about this. Okay, and you see the same thing happening here. We're getting the first notification, and then when the Lambda function processes our information, we get a second notification to update a message event. Now, there's also use cases where I want to get notifications for a chat room that I'm not necessarily in, right? So I can listen to one chat room at a time, but I may want to get notifications about things that happen in a chat room that I'm not currently in. So how do we do that? Well, we can do that by using the out-of-band type of notification. Let's see what that looks like. So if you look on the right, I'm in the random chat room. And on the left, I'm sending a message here into new meeting chat room. And even though I'm in the random chat room, I'm getting a notification about the message being sent to the new meeting chat room, right? So I've got a different type of subscription setup. And the way this is working is that anytime I send a message, my DynamoDB stream that's for my DynamoDB table where I have my messages set up triggers a Lambda function. And my Lambda function then tries to update all of my user conversations with the unread count, right? So this is an out-of-band type of change that triggers a subscription, right? And that subscription tries to update to unread count. So you see multiple subscriptions at play here. Now, we've got a lot of customers that are using AppSync. For example, Sky is using AppSync to innovate at a rapid pace. After deploying the first web component of its new serverless architecture, Sky Italia discovered that AWS AppSync decreased the time needed to propagate game data from a few minutes to milliseconds. So they used AppSync to move quickly and to implement applications to engage with their customers. Similarly, Cookpad uses AppSync to innovate quickly. Cookpad TV offers live shows put on by famous chefs and celebrities, and during the live broadcast, they allow audiences of thousands to make comments, chat, and like content. And we see AppSync being used across multiple industries. We have customers like the BMW Group that use AppSync to build scalable and universal APIs. There's also the Peacock streaming service that recently launched and has amassed over 26 million signups. They've used AWS AppSync as well to build their service. Or you've got Aldo in retail. Aldo used AWS AppSync to focus on implementing features in their application instead of managing their system and its infrastructure. So AppSync really allows customers to build universal APIs, consolidated APIs, and to move quickly. To connect your clients to AppSync, you have several options. You can use AWS Amplified Data Store that provides a local store at your client and works with Amazon DynamoDB data sources. You can use our AWS AppSync SDKs. The AWS AppSync SDK provides a local cache and supports any of your AWS AppSync data sources. Now, if any of those two tools do not work for you, you can also build your own custom implementation. You can build your custom real-time WebSocket client following AWS AppSync's provided spec and protocol. You can use any language that supports WebSockets, and you can implement your custom requirements and then deploy that wherever you need. So as we have seen, AWS AppSync allows you to start effortlessly and to scale your business. You can use multiple tools like Amplify integrations with the GraphQL transform to build quickly, or you can even use the AWS CDK and use their schema-first or code-first approach. Finally, I would encourage you to check out some of our AWS AppSync resources. Visit our website and other links on this page to find out more about what is going on in the AppSync community and what we've got going on in the AppSync space. Last but not least, also encourage you to visit our aws.com/training to find out more about our AWS training and certification. It's been a great time talking with you. I hope you learned a lot about AWS AppSync. My name is Brice Pele, and thank you very much for joining this session. Last but not least, before I go, please let us know about this presentation. Complete the session survey. Thank you very much.